For the sake of time, I know these are really long videos. I'm just going to go through this without talking. Pause it and let me know if you have any questions. Factor. I factored out the leading negative. Holes, none. Vertical asymptote, x equals 0. It's to the first power, so it's opposite. Horizontal asymptote, do I have a horizontal asymptote? No, they both have the equal degrees. Since they both have equal degrees, this is a -3 over a +1. Remember, you always look at the original. So we have a horizontal line at y equals -3. X-intercepts. Do we have x-intercepts? We do. The x-intercept is going to be at -2/3, 0. Y-intercept. Remember, for a y-intercept, you would plug in a 0 for the letter x. But remember, we would plug in 0 for the letter x. But we can't let x be 0. So the y-intercept's none. Let's graph. We have one vertical asymptote. It's going to be right there sitting on the y-axis. Let's write x equals 0. Remind ourselves it's opposite behavior. I drew one vertical asymptote, which means I have two branches. Let's go ahead and draw this asymptote at y equals -3. Let's say that's down here, because it is down there. There's no behavior or anything for the y values ever. Just write y equals -3. Let's plot this x-intercept -2/3, so go to the left of the origin. -2/3. Remember, it's straight through. And then that's it. That's all we have. Okay, so let's talk about how this graph has to look. Now again, I can pull up what I know is it has to go like this. It cannot start down here because it's hugging asymptotes. I wish I had a erasable pen up here, but I don't. Cross through, hook down to your other asymptote. Hop the vertical asymptote, draw the opposite arrow down here. You're going to have a little branch that just hugs the asymptotes. Okay, point of discontinuity, we didn't have any. -2/3, 0, it was multiplicity of 1, which means it went straight through. We did not have a y-intercept because we couldn't put 0 down there. Our vertical asymptote was x equals 0. It was odd behavior. I'm sorry, odd exponent, opposite behavior. Horizontal asymptote, y equals -3, oblique, nope, because we had a horizontal. Okay, next one. Woo! Last one. Thank goodness it's already in factored form, so I could put a check mark on that. For your holes, do I have any holes? Nothing cancels out, so none. Vertical asymptote, horizontal asymptote. I kind of analyze these together. Ooh, for the vertical asymptote, we're going to have 2. We're going to have one at x equals 2. By the way, it has opposite behavior. It's understood to be 1, but look at this. This is to an even exponent. So let's write x equals 5, and let's write same. Horizontal, I don't know. Let's look at the degree fight. There's 2 degrees at the top. There's 3 degrees at the bottom. So remember, when the denominator wins, it's y equals 0, which means we're not going to have an oblique. Let's go ahead and talk about these x-intercepts. That's going to come from the top. There's 2 of them. We're going to have 1, 0 with straight behavior, and we're going to have 3, 0 with straight behavior because they're both to the first power. Y-intercept. Well, we got to plug some stuff in and analyze it. Let's plug in 0. So when we plug in 0, that's going to be -1 times -3. That's going to be the top. When we plug in 0 at the bottom, that's going to be -2 times -5 squared, which is 50. So it's going to be a positive 3 over, I'm sorry, that's 25, guys. Negative 5 times negative 5 is 25. I got ahead of myself. Negative 2 times 25 is a negative 50. So our y-intercept is going to be a positive 3 over a negative 50, which makes the whole fraction negative. That's just barely below the origin. Let's go ahead and graph this. All right, so to graph, let's go ahead and identify our holes. Remember, we didn't have any, none canceled out. We do have x-intercepts. Remember, we had 2. One at 1, 0, and the other one at 3, 0. Both had straight behavior because it was to the first power. Y-intercept, remember, is 0, negative 350, so just barely below the origin. Remember, this is so exciting because we have 2 vertical asymptotes. We have x equals 2 with opposite behavior, and we have x equals 5, and this one had same behavior, so we definitely need to make a note of that on our graph. Horizontal asymptote is just going to be that x-axis. Let's write y equals 0. So we didn't have an oblique, so let's write none. All right, let's graph it. We're going to go in order up here. So we're going to have a vertical asymptote at x equals 2 with opposite behavior. And then go over a little bit because we also have another one on the same side of the origin. Remember, this is x equals 5, but this has same behavior. All right, after that, let's go ahead and bold out this horizontal asymptote. Let's write y equals 0. And then let's go ahead and plot both of these ordered pairs. We're going to have 1, 0 with straight behavior. Now, and then 1 at 3, so 3 is like right in the middle. And again, I know they're crossing these horizontal asymptotes, but never, ever, ever the vertical lines, so we're all right. Let's plot a dot barely below the origin for this y-intercept. And then that's it. We have everything we need, guys. So look, I know this graph is going in this direction because that's the way the ordered pairs go. So it's going to be hugging this asymptote, crossing through to the other side, and then hugging the other asymptote. We reminded ourselves it was opposite behavior. Hop over to the other side, draw the other opposite behavior. Ooh, I didn't put my arrow right there. Ooh. All right, it's there. All right, so it has to be down here. It's going to curve over. It has to pass through the doorway, and then it goes and hugs the other asymptote. All right, now we have same behavior. Hop over the other side of that asymptote and draw the same exact behavior. All right, now look, you don't have any doorway or anything. It's just a branch that's going to hug these asymptotes. And that's it for that example.